We're asked to use the definition of a limit to prove this one-sided limit. So if you're unfamiliar with what this is in section 2.2 of our textbook. We're choosing an epsilon that's greater than 0. We need to find a delta that is also greater than 0, such that if 0 is less than x minus 1, which is less than delta, which is, if you're wondering where the 0 came from, that's the limit that we're approaching. Okay, so we're trying to find a delta so that if we subtract these two numbers, their difference would be some sort of small number that we can choose delta. So if that's true, then the absolute difference between the two y values, right? So this is 4x minus 2. This is a y value that we get out of the function. And then if we subtract it by negative 2, that difference is supposed to be less than some epsilon that we're choosing. Because if you can show that it works for that epsilon, then you can show that the y values you're getting are getting infinitely close to some final number, which is what our limit would be. Okay, so what they've done is in the next step, we have this difference for those two y values. This is coming from the function, and then this is the limit that we're trying to prove, the negative 2. So if you subtract those two, it's supposed to be less than some sort of epsilon if the limit does exist. So if we try to subtract those two, if that's true, if it's less than some epsilon, then we got negative 2 subtracted by negative 2. That makes 0, right? So that simplifies to be just 4x, it's just less than epsilon, which implies that x minus 0 is less than epsilon divided by 4. They just divide 4 from both sides, from here from this inequality to this inequality. They just divide 4 from both sides. So that's why we're choosing our delta to be, in Greek over here, epsilon divided by 4. Okay, so now if that's true, if going back to this difference up here, now that we have something for delta, we can substitute epsilon over 4, and then this should still be less than epsilon over 4, because now we're valuing an absolute value. But we have, if we multiply both sides by 4, then we've got then we've got absolute value 4x is less than epsilon. So they just did some algebraic rewriting. They multiplied both sides of the inequality by 4, and then we can easily put this back into the form of the limit that we're trying to prove by saying subtract 2 and minus the negative 2. These are the two y values that we said the limit is approaching, and so that should still be less than epsilon there. Okay, so we know how to evaluate limits with our approximation methods. Plug in a number that's really close to x equals 0, just slightly bigger or slightly less than x is 0, right? Or we could look at it graphically. So this is like the more rigorous mathematical way of proving that this limit would be negative 2.